Okay, good morning everyone. I'm thrilled to be here. Love innovation. Firstly, I want to thank SA Potatoes for the opportunity to present our findings, and then also to Tanja for funding this very important project. I'm Dr. Debora van Merwe from Stellenbosch University, where I lecture at the Food Science Department. I lecture new product development, and I also do research on product development. I'm also a farmer's daughter with a renewed passion and interest in cooking with potatoes. It gives me great pleasure to introduce Tanja de Toit, who is an MSc student at our department. I asked Tanja to present her work today, as she has been actively driving and shaping her project. She's reimagining the value of what the market often disregards as a so-called ugly potato. Much like the tale of the ugly duckling that grew into a swan, this work shows how mishapen or blemished potatoes can be transformed into something beautiful and valuable, a high-quality multi-purpose flour with broad application in food innovation. Over to you, Tanja.
Okay, good morning everyone. My name is Tanja and I am the student, and I'm very excited to share a bit more about our project with you today. So I'm not going to go into this in too much detail since from the previous presentation I'm sure you know all about low grade and ugly potatoes. But yeah, most of these potatoes are currently being repurposed as animal feed, and some of them are also being sold at a far discounted price. And I was actually able to see this on Monday at the Johannesburg market. And although this does aim to reduce the losses, it does represent a missed opportunity in the food industry. So these low-grade potatoes can actually be processed into a shelf-stable potato flour, and this opens a new value chain from an underutilized crop. So potato flour actually already exists in the market. It is mostly used as a thickener in things like soups and sauces, and it's not very successful in baking, so it's mostly combined with wheat flour in baked products. And the main challenge here is obviously that potato flour does not contain gluten. So gluten is the protein in wheat flour that contributes to elasticity and structural integrity in baked products in the dough. So baked goods made with potato flour often turn out quite flat and crumbly. So to make potato flour, oh, sorry, I see now it never went to the... Oh, I'll give you a few seconds to scan through what I've already went through. This is the slide I'm on right now. So to make potato flour commercially viable in baking, the functional properties of potato flour needs to be improved or altered to potentially enhance its performance in baking applications. So potato flour is not the same as potato starch. Potato flour is made from whole potatoes, whereas potato starch is only the extracted starch component. So potato flour, therefore, obviously contains the whole nutritional profile of whole potatoes. So currently, as I've mentioned in the previous slide, potato flour is currently limited to its use as a thickening agent. And currently there is a rising demand for gluten-free products, especially in South Africa at the moment, due to a variety of reasons, mostly due to allergies. And potato flour is naturally gluten-free, which brings us to the potential here. So with the right treatment, potato flour can actually replace wheat flour entirely. And this can potentially then be suitable for various baked products. So that leads us to the study overview, which is to develop a potato flour from low-grade potatoes with improved functional properties for use as a gluten-free alternative, while also ensuring its commercial viability in the food industry. So the first objective was to evaluate the effects of enzymatic hydrolysis and different drying methods. to alter these functional properties I was talking about. And then we will also be assessing the commercial viability of the resulting potato flour as a multifunctional ingredient. So we investigated 2 different processing treatments. Firstly, we looked at enzymatic hydrolysis, where we used enzymes to alter the functional properties. And then in preliminary trials, we found that an enzymatically hydrolyzed potato flour had significantly improved baking potential. So I just want to note here this was preliminary trials, so it needs to be scientifically established yet, but very promising and very exciting. So before I go on, I just want to quickly give you an explanation of what this reaction is. So it breaks down starch into simpler sugars, such as glucose. So we specifically use alpha amylase and glucoamylase, and this is typically used in industry to produce glucose syrups, and also used to produce fermentable sugars in the alcoholic beverage industry. And what's very important here, why we went down this route, was in literature it has shown us that when potato starch gets broken down, it actually forms new connections within the potato matrix, and this can kind of act like a gluten network. So that network will replicate the structure of gluten, and that was what we were seeing in our preliminary trials. So, and then we investigated freeze drying versus oven drying. So we found that freeze drying resulted in potato flour with enhanced functional properties, especially when we were baking with it, and it also had a much lighter color, which is also desired. I'm just briefly going to go over the processing flow, but we started off with the low-grade potatoes, Sifra cultivar, class 3, and they were peeled, mechanically sliced, cooked and mashed, after which the enzymes were added, and the mash was then freeze-dried. And then in terms of the properties that we measure, we are looking at things like swelling power, water absorption, pH, color, water activity, pasting properties, and then we will also be conducting a full nutritional analysis. So these are the product characterization and features that are currently in progress, or things that we expect. So the nutritional analysis will likely show that it is high in energy and certain vitamins and minerals like potassium. And we are also conducting accelerated shelf life testing to ensure that it will be stable for a minimum of 6 months. And then we will also be designing a mock-up packaging design, mock label. We will ensure that it meets South African food regulations, and we will also test the feasibility through a realistic costing. So in terms of applications, so I think the potential here is that this flour, from our prelim trials, we have seen that it would be able to be used in various baked products, whether this is processed or just in the form of a premix with potentially no wheat flour added. And it's also shown potential to be used in baby food, as the treatment that we are doing has decreased its thickness and viscosity, and literature also suggests that this is what is desired for things like baby food. And yeah, in our preliminary trials we made a wrap, and we just used this flour without wheat flour and compared it to one made with just normal potato flour, and yeah, our one was definitely very successful. And then I also think it's important to note that we can target both the low-income and the high-income markets here, maybe positioning it as a affordable staple, or looking at things like a more niche gluten-free product. So yeah, overall, we have found that these low-grade potatoes can be turned into a potato flour, therefore, in a way, masking the defects of these low-grade potatoes in a processed form to reduce the losses. And we found that enzymatic treatment and freeze-drying also gave us a flour with improved functional properties, and this will potentially give us a safe and commercially viable alternative to wheat flour. So, yeah. Thank you.